Okay, so we took a look at last time a bit about autograph things, right? So what I was just kind of browsing this, and I noticed that actually it's I'd love to play with this a bit more, right? So then to play with TinyGrad, or even just Jags, right? What I found interesting here is that if you go through the examples directory, I mean, there's actually there is a simple simple neural network that is just very similar to what I was trying to do. Oh, there it goes. A simple neural net, which was very simple. It's very similar to what I was trying to kind of do. Here, if you look at neural network, right? So I kind of built a bit of a basic sketch of neural network with forward pass and whatnot, and then there was the backward pass, right? And so here we did a now an example of like, so that's what we did last time, right? So we were basically kind of hard coded sort of the derivatives based on we hard coded the stuff based on just the, I don't know, the chain rule and whatnot. I mean, I just, to be honest, used AI to generate those. But yeah, exactly. So, and what I wanted to try to do now is to just go ahead and say, can we use a sort of a standalone library like AutoGrad to actually do that for us? Because, essentially that's what you can do here, right? So you can, there's an example, right? And we could even take a look at this example and kind of use it to see if what we're doing makes sense or not. Epoch, train accuracy, test accuracy. I mean, we haven't done the accuracy part yet, and we should be, yeah, and we will probably be doing this soon. But I wanted to kind of linger. That's very, it's very, for his, I forgot his name. I'm just sorry. I have background noise that distracts me a little bit, but I need to get into this. And yes, the word linger reminds me a lot of that researcher in MIT that does podcasts, and it's called Lex Friedman. I don't know why, but that's what I was gonna say. And I'm I have a very blurred head today, so it's gonna be a fun video, I guess, a fun session. But let's try to use these. Like, let's try to just go ahead and use it. So there is, so even here, right? So you define that stuff, and then literally just call grad. Okay. First of all, let's see if we can install AutoGrad. How can I install AutoGrad? Can I just like install AutoGrad like this? Import AutoGrad and np. I mean, we can use it like that. So, but I think that copies the whole box in here, right? That's not what we want. But let's see. Let's try to. What I'm gonna try to do is I'm gonna try to replace. Let's do one thing first. Let's take a look at these. Let's do the train file. Let's do how many epochs? Let's do 5 epochs. Let's run these. Python train.py, right? That generates, what I want to do is I want to save whatever it generates, right? I want to kind of take a look at the time it takes. And then see if I just literally plug in the AutoGrad in there, whether that actually will improve it. And the way that we will be doing these, right, is so you import that stuff and then you define a function like these. And then you just do grad tanh. So essentially you just, can I just go to neural network, and then basically that's what I wanted to avoid. So we want to import import these. No, import autograd grad. Thinly wrapped numpy. I wonder whether you can just use. No, probably you can't, because probably that's how they listen to the whole thing. That's how they listen to, or that's how they basically. Yeah. Oh, wait a second. That finished already. It printed the whole thing in there, and so can I save this somehow? This output, or should I just, or do I have to actually just screenshot the thing? What's going on? What's going on? Anyway, it was fairly fast, to be honest. I don't know. I'm just gonna do it gut feel wise. It's very scientific. But what if I say I do these, and by the way, yeah. So what if I do these? Essentially, import like that, and then import autograd grad. Okay. Now the question is, I should probably install autograd, but the point is def backward, def predict, def forward. This is what we're doing. So this is what I was. Okay. So that's what we want to. This is what defines the forward pass, and that's what we want to then do the backward pass on, right? So then we're just gonna keep that as backward old, and then just define another one. Backward. That all it does is, how would you use that though? Obtain its gradient function. Obtain its gradient function. Evaluate the gradient at x1. I think it should still. I think you would still need to do. I think you would still need to actually take the same structure and then just evaluate the different gradients. Those are the gradients that we want to evaluate, right? Like those things in here. W2, B2, W1, and B1. Those are the things that we want to evaluate. I guess this is because you want the gradient, right? With x equals 1. So my guess, and we can take a look at the code later, right? But my guess is that's the way that it should be used. So essentially, the way that it should be used is nothing else than just taking these, right? And then saying, and then just I'm gonna assume that it's a minus here because it's gonna be standard. So what we should be doing, I'm just trying to think how you would typically plug it in here, right? That would be my guess, how you would plug like an autograd library to something like this. So wouldn't you just, I guess you would, you've got a function, okay, that you're defining, that's forward, right? And that's probably the wrong thing to do. Or not. Forward. The gradient, because we want to modify each of these things, right? At each of these steps. So I think that each of these things, W2, is what you need to, because here we're W2 to gradient. No, it's the loss function. That's it's bad. It's the loss function. And where's the loss function? Here? It's not here because we've defined it in here, which is very stupid. So that's the loss function. And so what we need in this loss function is actually a big thing that is constructed as what? It's basically the loss function is constructed out of these y true things, but then this y true is kind of, in this case, I think we have to define the loss function. Differently, right? Because I think we have to define the loss function as part of the neural network, because that's what we're doing the derivative of the loss function with respect to W2, with respect to B2, with respect to W1, and with respect to B1. And probably if I would go and take a look at the example, it probably looks like this. Not like that, but the example of the simple neural net. You've got the neural net, you've got log posterior, L2 norm accuracy, model training parameters, define objective. The objective function is what we, yeah, exactly. That's the objective function that we're trying to minimize. Yeah, and then basically get the gradient like that. And this one has the parameters. Okay, so that's a function of everything, right? So you've got the parameters. Yeah, you define, I guess that's the thing, right? So you define that loss function using all those parameters, and then no, but something makes no sense. And when is objective grad here? Atom. Oh, you need an optimizer, right? I can't optimize least step, wasn't. Why do you need an optimizer? The optimizer, what is the optimizer doing, right? So the optimizer is, what is the optimizer doing? The optimizer is just doing the loop, isn't it? I think the optimizer is just doing the loop, so we shouldn't care about these right now. What is the optimizer doing? We should just basically, the optimizer should just be just go through the steepest descent, right? Get gradient of objective. Okay, not that simple. So how would you plug this in here? Okay, that's good. It's a good thing. If you get stuck, it means you're on the right thing. You're doing the right thing. Because essentially, right, what the backward step is doing is it's doing this, right? It's calculating each of these derivatives, right? The derivative of W, like dW1 would be like, it's the derivative. Yes and no, right? Yes and no, because yes it is. It's always the derivative of the loss function with respect to W1. So you need all these parameters. So we need to build, first we need to build the loss function here, right? Or the objective function. Def loss. Let's stick to objective. Let's stick to objective because that's what they use and it makes sense. The objective function, and the objective function is essentially, so not these here, right? But the objective function should essentially be, that's what we want to do, right? So we want to do some, yeah, okay, but then y true is something that we need to basically build up. Because y true, right, in this case, we're just passing the results of y true, but not y true, but sorry, y pred. We're just passing the results. But here, what we need to do is we need to actually build y pred in as part of the loss function. Y pred is the output of the forward pass, correct? So we need to actually put in the, yeah, exactly. So of course, that's what the objective function returns, essentially, right? But then obviously y true is something that we need. But then instead of, we don't need y pred. What we need is we need y pred to just be the forward pass, right? So for the forward pass, we need For the forward pass, we need x. And then we have those parameters all like, okay, exactly. So really is basically x, right? And ypred is these. Ypred is these, right? Ypred in here is literally, oh, what happened? Loss function here. Ypred is literally the output of forward. So essentially you take in these stuff, right? You just make those things, I guess, do you just make those things variables? Do you just, I mean, they're part of the model. So that's what you, that's what you're doing. So ypred is basically this, and that's how you're building the function, right? So y true and x, that's how you do it. But now my question is, because that works well, right? Because you haven't that's what the optimizer kind of takes. The optimizer takes this grad function. This grad function is gonna have the parameters. These parameters are what? Param scale, layer sizes, all this stuff in here. Patch indices, IDX, train images, train labels. So it's really using all those parameters. I mean, it's quite interesting, right? Because it's actually using arrays and whatnot to define these, and it actually is able to deal with this. This is pretty impressive. This is actually very impressive. Let's just say it does this. It calculates the loss like that. But what I don't get is, how do I do? Okay, so how do I do something that's like the gradient with respect to a variable? How does it know? How does it know what are the parameters, right? So if I go back to here and to an example, that's fine. Pip install autograph. Maybe I should do this first, because I know that does not always work as fast as I think it does. So shell pip install autograph for sure. So let it install autograph, and then that is gonna give me autograph, like objective grad is gonna give me, but with respect to what? With respect to what? Tutorial. Let's say here I have a variable x, and then basically, okay, so I guess what it does is it's a derivative function across all the same dimensions. Really? How do I evaluate the gradient at x equals 1? Because that's the point, right? So the point of the optimization here is, okay, so that's how, because that's probably how the optimizer works. The optimizer probably, in a way, what the optimizer does is it changes the parameters, and then it goes with the high, where the highest decrease is. Yes, that is what now I wrote what the optimizers were doing. In order to plug this in here, essentially what are we doing with the backward pass? With the backward pass, we are just simply, we've calculated the derivative. We've calculated the derivative. And that already tells us how to optimize. So what are we doing differently here? So we've calculated the derivative. And that derivative, I'm creating a gap, I think, in my head right now between what am I really doing here and what is this thing doing, right? So because I know that that's the point of objective functions and doing things like this is that once you have the objective function, you're looking for inputs that minimize it. And so this means you play around with, it's a dimensional space. Obviously you have x, y, z, whatever one of variables. So this optimizes basically one of the brute force concept is very simple, right? So you keep replacing and iterating over different configurations of these parameters, and then go with whatever the thing gives you is like the lowest. So here what we're doing, I guess here what we're doing is one by one, right? So we're saying, okay, now let's just take a W2, do the derivative of these. Now let's just take a B2, do the derivative of that, with respect to that. Imagine everything else is constant. So it's exactly. So that's why it's a bit of a different approach, right? I wonder if there's a way, I know it's less efficient, but I wonder if there's a way to just kind of force that concept, right? And say, like, can I tell AutoGrad to just give me the grad with respect to a variable? Can I do that? Yes, I can do that. I can do that by just basically forcing the parameter. Yeah. I think that's, again, this is just, that's not what you should be doing. That's for educational purposes, I guess. Maybe I'll just keep the calling backward, but then I'll just basically say, yeah. Okay. What I'm thinking what I should do is these. So this is W2, right? And essentially that would be backwards W2. So we would need to kind of have multiple of these. I'm just thinking about what's the best way to what's the best way to do this, right? Because if essentially I'm just having another lapse right now. Why does this, okay, let's just, so that's my idea of how you would plug it in this naive way, right? Where you kind of basically say, okay, so that's my only parameter, and now I gotta build the loss function, the objective function like this. So the objective function is essentially these, right? But now we're treating or we're going to call this objective W2, and essentially W2 is a parameter. Everything else is what's fixed, right? So W2 is basically the parameter in here. So I would replace this with these, okay? Maybe param W2, like it's going to help make it more visual, okay? Everything else is what's in the actual yeah. Okay, so that's what we're gonna do exactly. So I think I can just replace beats, like I can replace beats like these. So I can now just say I have the objective W2, which is basically I have X, I have the and I have the parameter W2. So I build the whole thing and Y true, exactly. Yeah. X. The output is Y pred. But here we're not going to use the Y and then X. Okay. So what I want to do now is I've got objective W2 like this. That's how you would construct the loss function, but then leaving the W2 parameter unspecified. So I would need to call grad. So now I would kind of go here and just say, look, I'm gonna keep using this because I know that this is not needed anywhere else, right? So actually W2, this is what we will be replacing, W2, right? So for these, we would be able basically say grad W2 equals grad is objective this objective W2, right? Okay, but that's correct, right? So that's how you do these. You have 10H, you just say grad 10H, exactly. Yeah, exactly. And now we have grad W2, right? We want to evaluate these. So instead of doing these, right? I say, yeah. Wow. Let's see if that works. I'm curious if that works at all. And maybe to make sure that, like, what if we're just gonna look at these, right? Is this gonna, are we gonna get still like a downwards thing? You know what I'm trying to do? What I'm trying to do is I'm trying to kind of like say, I want to see if that replaces these, right? So I'm taking the objective function that I've defined with respect to W2. The problem is, well, I have everything I need to, because then essentially what I need to do here is just say now that dW2 is essentially an instantiation of these grad. So grad expects Y true, which is Y dist. It expects X and it expects W2. Yes. Self, sorry. Blah. The mental gymnastics that I've just done right now, I mean, this is like, if that works, I'm going to be like over the roof. But what we've essentially done is we've plugged in, we define a function that is just the objective function with respect to W2. And we're working without an actual optimizer, okay? So an objective function with respect to W2. And the way we define dW2 is basically by just getting the what is guard? What is guard? It's grad W2 and instantiating it by Y dist, exactly, all this kind of stuff, right? So this is Y true, so yeah. And then doing this. Okay, let's see if that works. Okay, so we're gonna do We're also going to do, hopefully that whole thing works as well here with autograd and whatnot. Furunculus. But what we're going to do is we should basically be able to just execute that and see what happens. And we'll leave it here, and regardless of what happens, okay? So Python train.py. Unless I get some funny errors or something like that. Okay, it seems to be working. But it's an overflow. Okay, it overflew. Why did it do an overflow? And now it didn't. Okay, I don't know. Now seems to work. Funny. It kind of did an overflow in the first. I have no idea. Autograd tracer is some overflow. So now it's doing it with autograd. It's not, it doesn't, feel wise doesn't feel like it's faster for these, right? But I guess the speed you're getting mostly with the optimizer, right? Rather than calculating the derivative. Although it would make sense that actually that is not faster, right? Because, well, faster is if you hard code the derivative. And in this case, I've hard coded the derivative, right? Because I've written, or I would have, like before, right? The commented, like, where is that? Where did I go? Where did I go? The previous W2 thing here was hard coded. And now, yeah, okay, but that's like, that doesn't show anything. That doesn't show anything at all. I'm gonna print the W2 values. Can we print those? And then we'll take it from there. But I think that's the right thing to do. I think that makes a lot of sense. Not the right thing to do, but like it's the right thing to learn. Okay, it's all nans. Essentially, it's all nans. That's why it doesn't do anything. So, not a number. Why is it not a number when it's basically grad instantiated with these? Okay, that will be the work of the next session. Bye-bye.